workbench. We'll take it one step at a time and explain each step as it is done. The acids, chemicals, and equipment used in the process will be explained and demonstrated as we go along. First, the flakes. These are the steps they went through in the refining process. It looks more complicated than it really is. One of these steps is repeated 5 times. We can simplify things by dividing the whole process into 3 separate stages. The first stage we'll call the pre-treatment. This stage is always the same. At some point, all material being refined goes through this process. In this stage, all remaining impurities are removed and the gold is melted into a solid form. For the time being, we'll just concentrate on the basic procedure. We'll go through these 5 steps one at a time and explain each one in depth. First, the aqua regia. This is the formula for aqua regia. Aqua regia is Latin for royal water. It is a mixture of 2 acids, nitric and hydrochloric. It is the only acid that will dissolve gold and platinum. Now, let's mix up a small amount and dissolve some gold. We'll use a small Pyrex bowl so you can get a good look at the reaction. The larger dish is to catch any overflow in case of a violent reaction. First, the nitric acid. That's about 20 milliliters. Now, we'll add 60 milliliters of hydrochloric acid. We now have 80 milliliters of aqua regia, which we will pour directly into the bowl. Normally, you would never be this reckless with aqua regia. It would be added a small amount at a time to control the reaction. We'll cut away at 5-minute intervals to show the reaction as it progresses. After 5 minutes, not much has happened. The gold is very slowly being eaten away by the acid. This is because the aqua regia is cold. 10 minutes later, the gold is still there, still slowly being dissolved. The solution is a little warmer, but it is also weaker. After 15 minutes, a good deal of the gold has been dissolved, but the larger pieces still remain. At 20 minutes, most of the gold has dissolved in the acid. All that remain are a few very thin flakes. After 25 minutes, all the gold has been dissolved. Actually, it is still there in the dish, but it is now in a liquid form. The solution can now be neutralized and filtered to separate any dirt or solid particles that weren't dissolved by the acid. Let's take some more of those flakes and go through that again but this time we'll do it quickly with a controlled, violent reaction. We'll use a little more gold and a larger beaker for this to minimize the chance of an overflow. Remember, we are using the same gold, the same mixture of acids, and the same conditions. The only difference will be the amount of gold and the way the acid is added. First, we'll mix up the aqua regia, 1 part nitric to 3 of hydrochloric. Now, we'll add just a small amount and wait for a reaction to begin. The reaction starts almost immediately, and red fumes begin to form. These red fumes contain chlorine gas and are an environmental hazard. The utmost care must be taken to avoid breathing these fumes. They are very unpleasant and can do a lot of damage. As we move in, you can see that there's a lot of action going on in the bottom of that beaker. This will gradually subside as the acid weakens, and we will have to add more acid to keep the reaction going. Most of the gold has been dissolved now, and it is safe to pour in the remaining acid. After a few minutes, no action can be observed, and we can safely assume that all the gold has now been dissolved. For larger amounts, like the rest of the flakes, we will use a large 6,000 milliliter boiling flask. With this type of container, we can easily control the dangerous fumes by venting them away from the work area. This is how it is done. All the work is done in a large plastic tub to contain any acid spills. The aqua regia is added slowly to the flask. As the reaction begins, a plastic vent pipe with a blower fitted to it is lowered over the neck of the flask. As the reaction progresses, any fumes that form are mixed with air from the blower and vented up the pipe and away from the work area. Commercial refiners must pass these fumes through a scrubber before they can be released into the atmosphere. Now, before we go any further, let's consider a few facts demonstrated by these two examples. First, the reaction of acid on metal generates heat. Heat increases the strength of the acid and speeds up the reaction. These two facts must always be considered when working with metal in a finely divided state. In the first example, a large amount of acid was combined with a small amount of gold. The result was a cold reaction, and the gold dissolved very slowly. Had there been more gold, or less acid, as there was in the second example, more heat would have been generated and the reaction much more violent. Here's another example of a controlled violent reaction, this time with very fine waste that contains gold, silver, copper, and other metals, along with a large variety of other impurities. As you can see, it is very important to control the reaction to avoid an overflow. With fine material, it is controlled by varying the amounts of acid added. With more solid, less volatile material, it can be controlled by varying the heat applied, as you will see when we do some solid scrap. Let's move on to step 2, neutralizing the solution. In this procedure, we will change the composition of the solution by destroying the nitric acid. When we do this, the solution is no longer aqua regia and cannot dissolve gold. To do this, we use a chemical called urea. This is what it looks like. It is added in small amounts directly into the solution. It reacts with any nitric acid that is present, which boils off, sometimes producing red fumes. The amount used varies. The general rule is to keep adding small amounts until the solution no longer shows any reaction. In step 3, we filter the solution